Section 10.0, real numbers. Our essential question today is how do you determine if a number is rational or irrational? We have a lot of new vocab words today. The first one is natural numbers. The set of natural numbers would represent the numbers that you learn about first. When you're really, really little, the first numbers that you learn are called the counting numbers, and they start with the number 1. So natural numbers are counting numbers. So they are 1, 2, 3, and so on. Then, when you are maybe in kindergarten, after you've learned about those natural numbers, counting up to 20 or maybe even up to 100, they teach you about one more number. And that one number is the difference between the natural numbers and the whole numbers. That number is 0. 0. So whole numbers are 0 plus all of the natural numbers. So you could say that the natural numbers are a subset of the whole numbers. The next set of numbers are called the integers, and the integers are defined as whole numbers and their opposites. So that means whole numbers and then their opposites would be negatives. So whole numbers and their opposites . So, like -2, -1, 0, 1, 2, and so on. Those are the integers. I like to think of them as the numbers that you typically put on a number line, especially if you label like your x-axis and your y-axis on a coordinate plane. Those numbers that you use are integers. So they're positive and negative numbers and 0. So the set of integers, if you look at the 3 sets that we've got so far, all of the natural numbers, that's a subset of the integers. The whole numbers are also a subset of the integers. So we're starting with a small set of numbers, and then we're expanding it. We're adding more and more to it. The next set is called the rational numbers. You may notice that the first 5 letters in the word rational are ratio. A ratio is a fraction. So rational numbers can be written as a fraction with integers in the numerator and denominator. So the numerator and denominator have to be integers. Irrational numbers. Well, if a number is rational, the opposite of rational is irrational. So for irrational numbers, I'm just going to say not rational. So you can't write them as a fraction with an integer in the numerator and denominator. And then real numbers, all of the above sets are part of the real number system. So real numbers is like the general category, kind of like if we were working with polygons and we said polygons could be triangles or quadrilaterals or pentagons or hexagons. Real numbers are like the big general set of numbers, and then we break them down within the real number system. You'll see that on the Venn diagram in the next slide. Okay, so, before we get to that, what is a subset? Which types of numbers are subsets of the rational numbers? Which types of numbers are subsets of the irrational numbers? Well, subsets of the rational numbers. So rational, we said, was anything that you could write as a fraction. With an integer in the numerator and denominator. So I'm just going to explain to you why these are subsets. Natural numbers are like 1, 2, and 3. You can put a 1 under them and make them fractions with integers in the numerator and denominator. Whole numbers, same thing. Here's your whole numbers. Put a 1 under them. They're all good. Integers, same thing. Put a 1 under them. Like that. Okay? So all of these are subsets of the rational numbers because you can write them as fractions. Irrational numbers, however, they are not a subset of rational numbers because they're the opposite of rational. And then real numbers, they're also not a subset because they are the big, huge category that include rational and irrational. The second question, which types of numbers are subsets of irrational numbers? None of them. None of them. There are no subsets for irrational numbers. They stand alone, which is what you can see in this Venn diagram. So we've got real numbers here describing the entire Venn diagram. So everything inside the rectangle is a real number. Once you're inside the real numbers, irrational numbers are over here by themselves, while rational numbers have subsets inside them, integers, whole numbers, and natural numbers. So as I click and drag these numbers, I'm going to start out with the natural numbers. I am looking for counting numbers first. Counting numbers first. So the number 5 would be a counting number. So would the number 13. And if I simplify the square root of 36, I get 6, which makes it a counting number. So 5, square root of 36, which is 6, and 13. Whole numbers, the only thing that I can add is 0, because that's the only difference between the natural numbers and the whole numbers, 0. Now integers, what should I be looking for my integers? If I've already got my natural numbers, and I've already got 0, what did the set of integers add that was new? It added the negatives, the opposites of the whole numbers. So there's an integer, and there's an integer, and this one is an integer also, because it would be -5 if I simplified it. -5. Okay, I don't see any more integers. So now let's move to the rational, the fractions. Well, 3½ or 7/2 is a fraction. -4/5 is a fraction. If I simplify this one, I get 4/7. So that's a fraction with integers in the numerator and denominator. Now let's talk about decimal numbers that you can write as a fraction. 0.3 repeating is 1/3. 5.7 is 5 7/10. 0.35 is 35 hundredths, so 35 over 100. And -15.725 is -15 725 thousandths. There, we're set. Now the rest of these things, if you have a decimal that does not repeat and does not end, that is irrational, just like pi. Pi is irrational. So I call those bad decimals. They don't end, and they don't have a repeating pattern. Square roots that are not perfect squares give you just that type of a decimal. So square roots that are not perfect squares, pi, and bad decimals that don't repeat and don't end. That represents our irrational set. Okay, this next one says to classify each of these numbers as either rational, irrational, both, or neither. Well, if you pay attention to that wording, we're classifying each number separately. Numbers cannot be both, and they cannot be neither. They are going to be rational or irrational. So, rational, I can write as a fraction, I can write as a fraction, I can write as a fraction, so it is a fraction. This one would be 3/4. This one is 8, because it's a perfect square. This one's a repeating decimal, so that would be 5/9. There we go. So there's only 3 that are irrational here, a square root that's not a perfect square, pi, and 1 bad decimal that doesn't repeat and doesn't end. Put these in order from greatest to least. From greatest to least. Well, 4.3, so we're trying to go from greatest to least. So I know 4.3 as a decimal is bigger than pi because pi is 3.14. So I'm going to write that by pi, 3.14. So I have used 4.3 and pi. -2 is a negative number, so I'm going to put that one way down there, I would assume. Because I don't see any other negatives. So now it's just a matter of the square root of 8. Well, I know the perfect squares on each side are the square root of 4 and the square root of 9, which equal 2 and 3. So that means if it's between 2 and 3, I've got 4, 3, between 2 and 3 is going to have to put it over here. And then 16/3, if I divide 16 by 3, 3 times 5 is 15. So I know I've got 1 left over, so 5 1/3. So that makes 16/3 the greatest, if it's 5 1/3. Be careful with the wording because sometimes it will say least to greatest and other times greatest to least. All of these problems are very similar to what you will see on Study Island in the wording and what you could see on your MCA. This next question says, what kind of numbers are included in this set? Now this is an entirely different question than the slide that we saw a couple slides back, where we were looking at one number at a time. Now we're talking about the entire set. So the entire set could be rational numbers, irrational, or both. It's not going to be neither. It's not going to be neither. So rational, irrational, or both. Well, pi is irrational. The square root of 4 equals 2, so that one's rational. Square root of 11, irrational, not a perfect square. Square root of 7, irrational. And square root of 16 equals 4, so I have both in this set. I have both rational and irrational. If you've even got one of each, I could have stopped after the first two and said both, because the first one was irrational and the second one was rational. Now, fill in the blank. Pi as compared to the square root of 9. Well, the square root of 9 is 3, and pi is 3.14, so 3.14 is greater than 3. Square root of 11 compared to 1.75. The square root of 11 is between the square root of 9 and 16, so it's between the numbers 3 and 4. That is greater than 1.75. 5 compared to the square root of 5. The square root of 5 is between the perfect squares 4 and 9, so it's between 2 and 3. 5 is greater than something that's between 2 and 3. And the square root of 31 compared to the number 53. 31 is between the perfect squares 25 and 36, so it's between 5 and 6, much smaller than 53. Which statement is true about 10 times the square root of 13? Well, the square root of 13 is an irrational number, and 10 is rational. So what happens if we multiply these numbers together? Well, the square root of 13, we know that's a bad decimal. It's a bad decimal. It's between 16 and 9, a little closer to 16. So it's between 3 and 4, a little closer to 4. So let's say it's like 3.5612 ... I really don't know. I'm just making something up. But my point is, if you multiply by 10, it's just going to move the decimal point over 1. It's not going to turn this into a nice decimal at all. It would be like 35.612 ... That bad decimal from square root of 13 is still going to be a bad decimal. So it is going to be irrational. It's going to be irrational. So if you multiply a rational times an irrational number, you get another irrational number. The same thing happens if you're adding. Because 13 plus the square root of 60, well, this is between 64 and 49. So between 7 and 8, closer to 8. So let's say it's like 7.72053 ... If I add 13 onto that, I'm only changing the number in front of the decimal point. I'm not changing the bad decimal part of it. So it's still going to be irrational. So this one I've got a rational plus an irrational number, and it still ends up irrational. So adding or multiplying one of each, one rational, one irrational, stays irrational. You should be able to write your summary now. Remember, we're focusing on rational versus irrational, how you make that determination. And your homework is in your worksheet packet. There's a page that says day 2. So you want to do that page all the way up until you get to the one that says day 3. That's where you stop. So stop when you get to the page that says day 3. Do all of the ones after day 2.